So we've been talking about multiplying binomials and polynomials. Today we're going to talk about factoring polynomials. And when we're factoring a number or an expression, we're just dividing out the common factors. So today we're going to start doing this by looking for the GCF, which is the biggest number that can be divided out of two or more terms. And when we do that, we're going to rewrite the expression as the product of those two factors. So today we're working backwards. Instead of giving the factors and multiplying them together, we're going to be starting with the final answer and factoring out those two factors. So to start doing this, we're going to first divide out the common numerical factors. So what numbers do they have in common that I can divide out? Then we're going to look at if they have any common variables. So do they both have an x or do they both have a y? And then once we find all of our numbers and variables that they have in common, that's our GCF, and that's going to go outside of the parentheses. And whatever's left over that does not have a common factor goes inside of the parentheses. So we're going to go ahead and jump in. We're just going to start off with factoring regular numbers as a review. I'm going to use the ladder method for this, which is just an upside down division symbol. I'm going to put 18 and 12 inside, and then I'm going to go ahead and start looking for numbers that they both have in common. So right off the bat, they're both even, so I can start with a 2 and say 18 divided by 2 is 9, and 12 divided by 2 is 6. When I do that, they still have a common factor. They're both still divisible by 3, so I'm going to add another level and divide a 3 out. 9 divided by 3 is 3, and 6 divided by 3 is 2. Now we have 3 and 2, and they don't have any common factors, so whatever is divided out on the left is our GCF, and whatever is left over in the bottom did not have a common factor to divide out. So for this, our GCF equals 2 times 3, which is 6. They were both divisible by 6. So go ahead and try number 2, pause the video, and see if you can find the answer for number 2. All right, so now we're going to move down and factor an expression. So I'm going to go ahead and put the whole expression in my upside down division symbol. And I'm first going to look for our numbers. So this coefficient, we have a 2, and this coefficient, we don't have it written out for us. So remember, when that happens, we have an imaginary 1 out front. So we cannot divide anything out of 2 and 1, so we don't have any numbers to divide out of both. So now we're going to look at our letters. And here we have an x squared, and here we have an x. So we can at least divide out an x from both terms. So when I say 2x squared divided by x, I just get 2x. When I say 1x divided by x, I just get 1. So they don't have any other factors in common. X is our GCF. So when I rewrite this expression, I'm going to write it as x on the outside, which is our GCF, and our leftover factors that didn't have anything in common go back inside. So that is our factored expression. So you go ahead and pause the video and try number 4 and see how far you get. And then we're going to go ahead and try number 5 together. Same deal. This one looks a little scary, but it's the same process every time. We're going to put our polynomial inside the house, or the upside down division symbol. The most important thing is to make sure that you're bringing down everything that we haven't taken out yet or divided out yet. So first, I'm not even worried about the letters. I'm just looking at the numbers. I've got 20, 45, and 35. So I know at least I can divide out a 5 from each term, so I'm going to use that as my starting point. 20 divided by 5 gives me 4. I'm going to bring down everything else attached. 45 divided by 5 gives me 9. And 35 divided by 5 gives me 7. So I'm going to take another look back at the numbers. I've got 4, 9, and 7. And those don't have any factors in common, so I can't divide out any more numbers. Now I'm going to look at my letters. So I'm going to start with the fact that they all have an x. So I'm going to divide out an x. So I'm going to have 4x instead of x squared because I divided one of the x's out. And then in the next term, I'm going to have 9x instead of x squared because I divided an x out. And in the last term, again, I'm going to have a 7x because I divided an x out. Now I'm going to look back and see if we have any x's left over. Each term still has an x in it, so we're going to divide out a second x from each term. So when I divide that one out, I'm just left with 4y squared here. When I divide that one out, I'm just left with 9y. When I divide that x out, I'm just left with 7. I'm going to do one more check for common letters. There's no more x's, so now I'm going to check for my y's. I only have a y in this term and this term, so since I can't divide out a y from every single term, I don't have any more common factors. So this is going to be my GCF. 5 times x gives me 5x squared. Then everything left over that did not have a common factor goes inside of the parentheses. So that would be our factored expression. Go ahead and pause the video and try out number 6.